Okay, I said. Physical science time. Comrades. Physical science time. We're going to write down energy. This is... Thank you for making that grinding noise, Justice. That's really pleasant. We all like that. Okay, talking about energy. Have you heard of energy?
Yes. What's energy?
Great question, Peyton. Peyton wants to know, what is energy? Give me a little definition from your own Dave Smith. What is energy? Leo? Power. Actually, power has its own specific definition in science, which is different from that of energy. But in our daily usage, we might relate those two things to one another. Because you're thinking of like electrical power as it compares to electrical energy. And those two things even have specific definitions. But when else do we use energy? Thank you, Leo. When else do we use
We brush our teeth.
Okay, very specific example. We use energy when we brush our teeth. Yeah, we use kind of this like metaphorical idea of energy to be like, I don't have energy to go to the dance tonight, or I don't have energy to make chili for my family. I don't have energy to walk the dog. We don't really mean we don't have physical, scientific definition of energy, because we do, but we may not have the mental or spiritual energy to get us through the day. You know what I mean? But it's still, all of this kind of relates to the same thing, and it's in the same category of our definition of energy, which is, if you remember from your vocabulary, the definition of energy that we use scientifically is what? What would your vocab say?
Joules.
Okay, yeah, we use the unit joules.
1 second.
I'm too cool, Justice, to joule in school. But we use the unit joules, spelled not like a cigarette. We use the unit joules to measure energy, yes.
Joule.
Joules, yes. But what is, Rhett, would you remind us of the definition of energy?
There's a lot of different kinds of energy.
There are a lot of different kinds of energy, yes, but all of them, and even the kind of energy that we were talking about, the spiritual energy that we have to do something, all of this relates to what energy is, which is the ability to cause what very broad thing, one of the broadest things in the universe. It causes what?
Movement.
Not just that. That could cause that, yes. But that's too specific even. That very broad thing, movement, is too specific. The ability to cause change. Thank you, Tiana. Change. The ability to cause change. If I say I don't have the ability, to walk my dog, or if I don't have the energy, I should say, to walk my dog, then it's a change that I'm not. The change being my dog needs to get from here to there. I don't have the ability. I probably physically do. There probably is physical energy in my body enough that I could cause the change in movement of myself. I could drag the dog along the log. Sometimes it feels like that. Drag the dog along behind me. But energy is just the ability to cause change. And there are many different types of energy. Let's talk about the types of energy. Types. Examples. What are some examples of specific scientific energy? We're not talking about, yes, thank you, kinetic. We're not talking about, now in this case, the metaphorical spiritual energy. We're talking about scientific energy, the ability to cause change in the environment. So there's kinetic energy, which is the energy of, I'm going to do this. I'm going to say its name over here, and it's energy of what? In kinetic energy's case, it is the energy of what? Of motion. The energy of motion. We'll talk more about the math of kinetic energy next time we meet, but right now I just want to get the definitions pumped out here. Potential energy, and there are lots of kinds of potential energy. And this is the energy that is what? Well, I shouldn't say energy of, but this is energy that is, energy of position, we can say. I'm going to put in parentheses that it's stored energy, because we do sometimes think of it that way. And there are several different types of potential energy. What are they? What are some? I can think of 3.
Elastic.
Elastic. Which is the energy of stretchiness.
Yeah. Chemical.
Which is the energy of the energy of bonding. We'll talk more about that later on in the year. And gravitational, which I'm going to put here, is the energy of height. My storm glass, which I think you can see on camera. Can we? If I indicate this, can you see that on the camera? That thing up there?
No, you cannot.
Okay, well there is a thing up here, a mystery thing for the viewers online, where it's called a storm glass, and that thing's up high. And it has energy because it's up high, and that's called gravitational potential energy.
You can almost see it, like it's barely out of view.
Good. It's a secret.
On the elastic.
And I put PE after all these. What's PE stand for? Physical education. Now, potential energy in this case. Elastic potential energy, chemical potential energy, gravitational
What's the word
potential
to
energy.
that? Elastic.
That's
Height.
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 Elastic.
Oh, stretch. Yes.
What would be an example of potential kinetic energy?
Well, kinetic energy is different from potential energy, but things can have both. And what we're really concerned about in this in this chapter, and we're going to talk about the math behind this next time, but we're really concerned about energy can change form, right? It can change from, for instance, how could I make the storm blast change from having gravitational potential energy to kinetic energy? Cause it to change from having height energy to movement energy. Yeah, I could knock it over. If I knock it off, which I'm not going to do because it was expensive, I bet. It was for my birthday. It would make me sad. But if I knock it off, it would change from height to movement, and it can change form. Usually pretty easily, right? It costs energy. But energy can change form, but cannot what? Be what?
Well, energy can't be made or
Yes,
destroyed.
exactly.
So.
Cannot be created. I'm going to put created, but you're right. Or destroyed. So the total amount of energy, even if I knock this off, the total amount of energy it has, as it falls, it's changing from up high to fast, right? It's getting faster and faster as it gets lower and lower. And then when it breaks on the ground, even that is still, what does it turn into? Sound energy, friction, deformation. The glass itself has probably broken because of that energy that was held in the glass is now released into the environment, probably as thermal energy, as friction. But the total amount of energy is the same. So before, if we have a little graph, before we have GPE, KE, we have thermal energy. Before it was all this, right? Before it fell. And then as it falls, it's part this and a little bit of this. And then when it gets to the bottom, it's probably all that. Does that kind of make sense? So the total amount stays the same. And we call this this idea, that energy cannot be created or destroyed, the law, I'll give you a hint, of,
Conservation.
there you go. Law of conservation, we talked about this last year, of energy. Questions? You have questions?
Yes, I have a question, sorry.